dependency rules, and then we'll go. So this is the relational algebra part of the equation. If A implies B and C, then A implies B, A implies C. If A implies A comma B implies C, then neither A nor B determines C by itself. I think it's important to understand this because if A implies B and C, then A implies B and A implies C. Let's take an example. If A is somebody's social security number, then let's say it implies name and the year of birth. So A implies name, which is B, year of birth, which is C. So social security number, from a social security number, we'll be able to find somebody's name. We'll also be able to know somebody's date of birth. So A implies B, comma C, then A implies B, A implies C. If A and B combined implies C, then neither A nor B determines C itself. So let's take somebody's name. Let's assume that there are multiple John Smiths in Atlanta. So somebody's name will not determine John, to determine a unique John Smith, we need to know, in addition to Atlanta, maybe his driver's license number. So we can say driver's license number and the city the person lives in determines C. So when two components determine one thing, like another example, there might be I think Atlanta is famous for that. You might have a street and a zip code which identifies a residence. So just by a street, you cannot find the location of a residence. Similarly, just by zip code, you cannot find the location of a residence. So A and B combined determines C, where the location of a residence, but neither A nor B itself determines C. Everybody follow this? This is like there will be lots and lots of questions on this. Does everybody follow it? Everybody can hear me, everybody can see me, and everybody follows me. Is that right? Is there no to any of those? Okay. Let's go. Okay, so let's go look at this table. Functional dependencies in the order item table. So just keep this in mind, order entry table has order numbers, school, quantity, price, and extended price. If you look at this, order number and school number determines quantity, price, and extended price. So if you look at this slide, look at this. Order number and school number are determining for each order number associated with each order. There can be multiple SKU numbers. So if you look at order number 1000, if you look at right here, it has one SKU number, two SKU numbers associated with it. So order number itself does not determine quantity, price, or extended price, but order number and SKU number together determines. So if you say order number and SKU item, what you are ordering, it determines quantity, price, and extended price. Same example, you went to Amazon, you bought 5 iPads and 3 laptops. So the SKUs that you're using too are iPads and laptops. So one, to determine how much you spend on iPads, you must know the order number and the SKU number. So the functional dependency example, we have order number and SKU number, which determines quantity, price, and extended price. Similarly, quantity and price, if you look at it, so by knowing the order number and SKU number, I can find out or determine quantity, price, and extended price. Similarly, quantity and price determines extended price, because extended price is nothing but price multiplied by quantity. So price and quantity determines extended price, order number SKU determines quantity, price, extended price. Okay. You will use these things, these kind of things all the time in the class and in the, who doesn't get it? Who doesn't understand this? But how do we go from this to this to this? If you don't understand it, tell me now, because it will be very hard for you to understand later. Who do not get that? In the dependencies, don't we have a rule where we have to multiply the two? No. This dependency, this is logical dependency. If you look at this, you can say, can I determine the quantity, price, and extended price of, I can determine the quantity, price, and extended price of something, of an order, if I knew the order number and SKU number. So that's what it is saying. You don't have to multiply anything. These are logical, conceptual concepts. These are not calculations. These are absolutely not calculations, because these are just showing that there is a relationship. There is a, in order that if I knew the order number and SKU number, I will be able to predict, or I will be able to determine the quantity, price, and extended price. Similarly, if I knew the quantity and the extended price, well, somebody says, are we not supposed to be taking the quiz now? No. The quiz will be at the end of the class. I think I said between 9:15 and 9:30 sometime. Functional dependency, the order number and the SKU number determines quantity, price, and extended price. Similarly, if you knew the price and quantity, you will be able to determine the extended price. The determinant is unique in relation if and only if it determines every other column in the relation. Okay, this is a good concept. The determinant, now we know what the determinants are. We know how they are determining. The left-hand side is called the determinant, and the value which is determining is on the right-hand side. A determinant is unique in relation if and only if it determines every other column in a relation. So if one determinant on the left-hand side, it determines everything else but is left in the table. So let's say the table has 4 columns, and there is one column who determines every other column, then the determinant is unique. Example, social security number. So let's say you have a table with social security number, first name, last name, age, and sex. In most part, a social security number determines every other attribute, first name, last name, age, and sex. So the social security number is called a unique determinant. The house number, let's say, house number in address, or the if address determines the size of the house, how many floors it has, then we have a basement, the color of the brick it uses. If all these characteristics are determined by the address of the house, then the address is a unique determinant. You cannot find determinants of all functional determinants simply by looking for unique values in one column. So how do we find determinants? And you have to do the kind of logical thinking the way I was showing it. So that's how you find the determinant. Okay, a key is a combination of one or more columns that is used to identify rows in a relationship. So you will be talking about keys all the time. What is a key? A key is a combination of one or more columns that is used to identify rows in a relationship. Let's say you are working in a corporation and they are storing information about you. And most of you know, they will assign you something called an employee ID. So the employee ID is a key that identifies everything about you, and so that employee ID is a key. Social security number is a key. If you go to the Priceline or it's Expedia and you reserve or book something, they give you a reservation ID. That's a key. If you call a hotel and say I book a room, they give you a reservation ID, a confirmation number. That's the key. Anything you do where they somehow identify you, every car has a VIN number. So to get that is a unique identifier for the car. That's the key for the car. If you had a car table where we are storing information about the car, that will be the VIN number, which is the primary key. If you are, so this is the examples of lots of keys. In real life, we have every single system in the world uses some kind of ways to identify who you are without typing in your name or a key. A composite key is a key that consists of two or more columns. Okay, somebody asked a question, how is it different from a primary key or a foreign key? We're going to talk about that from in later. A composite key is a key that consists of more than one column. So if there is more than one column that identifies every other column, then it's called a composite key. Okay, so now we're going to go to what the questions that we have been asked of. A candidate key is a key that determines all other columns in a relationship. So if the key is determining all other columns, then it's called a candidate key. So besides itself, it determines everything else. That's called a candidate key. The primary key is the candidate key selected as the primary means of identifying roles in a relationship. Okay, so a primary key is a candidate key that identifies all other columns in the relation. There is only one primary key per relation. The primary key may be a composite key. The ideal primary key is a short, numeric, and never changes. Karam, does it answer your question? The primary key is a key which determines a candidate key which determines every other value, every other column in the relation. There can be only one primary key per relation or per table. The primary key may be composite key. It doesn't have to be one column. It can be more than one column. It can be two columns, three columns. The ideal primary key is a short, numeric, and never changes. Surrogate keys. Again, we're going to go through a lot of concepts. A surrogate key is an artificial column added to a relation to serve as a primary key. This is surrogate keys are usually auto-generated by the database management system. So it is something that is not part of the data itself, but for various reasons to make things more identifiable in order to sometimes it is prudent to create some unique keys if the system doesn't, it is not suited to have some numbers assigned to it. The DBMS automatically creates assigns it, so you can say, I really don't have this information when I got it, didn't have really some kind of a key associated with it, but it is easy to track data in a DBMS in some form of keys, some numeric, short numeric type of keys. So let the database, when I store the data into the database, let the database assign it some unique keys, and the database can do it automatically. So these are artificial, meaningless to the user, like in a great example of a surrogate key is probably, like you go to a driver's license thing and you're waiting for your number to come up, and they give you a card saying you're number 26. That number 26 is important for the system because the system knows now there are 26 people in line, and it uses that information to maybe plan how many tellers they should have, what is the average wait time, lots of other information. But really, it might be important to the end user just for that fraction of a minute or the amount of time that they are waiting there, because they see that 26 means they are coming up. But for the database, it is a lot more meaning. So to the user, it is kind of meaningless. Maybe there's a little bit of value just to know that you might be your card is coming up, but for planning purposes, the system has got more value. So that's an example where a surrogate key might be created by the system to keep track of it. And there are lots of, there are times when we use surrogate keys just because there is no great way like, if you call your pest control company and you say, okay, I need some pest control service. They do it. They type in your address and they say, okay, when you need it, when you have people. But addresses are, anytime you type something alphabetic, they're notoriously difficult to match. So internally, they probably assign you some kind of a number within their system. But those numbers are not relevant to you. You don't call them up and say, oh, I need a pest service. My customer ID is XYZ. and 12395. Nobody remembers that. So they somehow try to for systems when they talk to each other. Maybe the front-end systems, I do the match with the names, but their billing system, their customer relationship management system, systems in the back-end time somehow create an employee ID, which anytime you go in, it just assigns to the next one. System automatically assigns to the next one because it's not like your social security number which has real value. This one is somewhat valid only to the system. Okay. Anybody has any questions? So we'll go through, I think this is kind of in the middle. We're half the chapter. So what I'm going to do now is, if you have any questions, ask me now. What I'm going to do now is send you in next couple of minutes, I will stop sharing this. I will send you the quiz, email all of you to Desire to Learn. And once you finish it, you can upload it to Desire to Learn. If you have any problem uploading, just email it to me. I'll start sending it. As soon as I send it, I'll tell you. Probably you should get all of them by 9:25, and you have till 9:55 to upload it. All right, let me close this. Okay, what's going on here? Okay. Okay, I just sent it out. So, have you should have received it. Let me know if you didn't.